Hello, everyone, and welcome back to the Kaspa Miniseries. I'm Alex. In this series, we are compressing the epic 7.5-hour The Bitcoin Takeover podcast into small, powerful highlight episodes.
And I'm Jamie. We've covered why Kaspa exists, the founder's journey, and the philosophical divide with Bitcoin. But today we are going deep into the engine room. This is the episode for everyone who has looked at that wild, flowing Kaspa visualizer and thought, what on earth is actually going on here?
Exactly. Today's episode is called What is GhostDAG? We're going to break down the core consensus protocol that makes Kaspa possible. This is the technical magic that allows for those 1-second blocks without sacrificing security.
And to do this, we're pulling directly from Jonathan Sampolinsky's explanations in his marathon interview with Vlad. He started by making a really interesting point. The core idea behind Kaspa is actually quite simple, if you already understand Bitcoin.
He said the fundamentals are 80% are like Bitcoin. He sees Kaspa as a generalization of the Bitcoin protocol. So, to understand GhostDAG, we first have to understand that generalization. Let's start with the absolute basics. A blockchain versus a BlockDAG.
Right. A traditional blockchain, like Bitcoin's, is a single file line. One block after another after another. If two miners find a block at the same time, only one gets to be in the line, and the other is discarded as an orphan. It's a single-lane road.
But Kaspa doesn't use a chain. It uses a BlockDAG. DAG stands for Directed Acyclic Graph. What does that mean in simple terms?
Think of it as a multi-lane highway instead of a single-lane road. In a BlockDAG, blocks can reference multiple predecessors or parents. So, if two blocks are mined at the same time, the next block can simply point to both of them. No block is an orphan, all work is included. As Jonathan explained, you envision many miners creating blocks in parallel very fast. Then you get this messy, supposedly messy graph of blocks just growing.
Okay, so we have this big, messy web of blocks instead of a neat line. But that creates a huge problem, right? On a single-lane road, it's easy to see who's first. On a multi-lane highway with cars everywhere, how do you create a single agreed-upon order of transactions?
That is the exact challenge. And this is where GhostDAG comes in. Jonathan was very clear about this. He said, the innovation is not in the DAG, rather in the way you order messages or blocks in the DAG. The structure creates the potential for speed. The ordering rule is what makes it a secure consensus protocol.
So how does GhostDAG create that order? Where does it even start?
It starts with a simple, visual intuition. Jonathan argued that if you look at the graph of all the blocks, you can actually see the honest part of the network with your own eyes. He said, you can identify the set of honest blocks just by looking.
How is that possible? It just looks like a tangle of connections.
Well, he explained that you have to know one piece of information. There's an upper limit on how long it takes for a block to travel across the network. This is called network latency. Because of this, blocks created by honest miners will be relatively close to each other. They'll be well connected. An attacker trying to create a secret, separate part of the DAG will naturally look disconnected from the main busy cluster of honest blocks.
Okay, so you're looking for the busiest, most interconnected part of the graph, the city center of the block highway, not some lonely road off to the side.
That's a perfect way to put it. The GhostDAG protocol formalizes this intuition. Instead of Bitcoin's longest chain rule, Kaspa uses what Jonathan calls the heaviest cluster rule. The protocol identifies the main well-connected set of blocks, the honest cluster, and uses that as the primary reference for ordering.
So it's essentially a voting system where each block votes for its parents, and the protocol finds the group of blocks with the most votes, or the most weight.
Exactly. This heaviest cluster is technically called the K cluster. The K is a parameter that represents the network's latency. The protocol looks for the set of blocks that are all within K connections of each other. This becomes the spine of the DAG.
So once the protocol identifies this main spine, or heaviest cluster, how does it create a final linear order for all transactions?
This is the final, clever step. Within that main cluster, the protocol identifies a central chain of blocks. This isn't the longest chain in the Bitcoin sense, but rather a well-connected path that serves as a primary timeline.
Like a main street running through the city center.
Perfect analogy. The protocol then uses this main street to sort everything else. It walks along this central chain, block by block, and at each step, it looks at all the other blocks connected to it, the side streets and alleyways. It then uses a specific set of rules to sort those blocks and add them to the final history.
It's a process of linearizing the DAG, as Jonathan called it, in a way that every node in the network is guaranteed to arrive at the exact same order. So let's break that down. Step 1. Miners create blocks in parallel, referencing multiple parents to form a big, tangled BlockDAG. Step 2. The GhostDAG protocol identifies the heaviest cluster, the most well-connected part of the DAG, representing the work of honest miners. Step 3. It finds a central chain within that cluster to act as a timeline. And step 4, it walks that timeline and sorts all the other blocks around it to create one single consistent history of transactions.
You've got it. That's the essence of GhostDAG. It's a system designed to embrace the messiness of parallel block creation and turn it into a strength. All that work that would have been wasted in an orphan block in Bitcoin now directly contributes to the security and weight of the honest cluster.
And this is what allows Kaspa to have such a high block rate. Because it doesn't matter if 2, 10, or even 100 blocks are created in the same few seconds. The protocol is designed to take all of them, find the center of gravity, and methodically sort them into a single history.
Precisely. This is why Jonathan describes it as a generalization of Nakamoto consensus. It takes the core idea of weighting work, but applies it to a much more complex, parallelized structure. It solves the speed versus security trade-off by ensuring that more speed and more blocks just means more data for the ordering algorithm to work with, reinforcing security rather than weakening it.
It really is a fascinating piece of engineering. It's complex under the hood, but the result is a system that can theoretically scale to the speed of the internet itself.
And that's our deep dive into GhostDAG. It's the technical heart of Kaspa, and understanding it is key to understanding the entire project. In our next episode, we're going to explore the future of Kaspa, DAGnight, the next evolution of the protocol designed to make it even faster and more resilient.
Thanks for tuning in to the Kaspa Miniseries.